Then we have the stateful firewalls, which this is going to be the main topic for today as well, where traffic is going to be controlled as opposed to stateless firewalls on a session by session basis. So a stateful firewall as opposed to a stateless firewall is going to allow traffic back and forth, is going to keep track of the allowed traffic in a state table, so it's going to be able to identify the session state and better inspect the packets to make sure that nobody is able to inject spoofed packets within a session, like spoofed sequence numbers. Also, the stateful firewall is going to be also an ALG, so understand certain applications. It has better support for protocols that are based on multiple sessions, like one control plane and one data plane, like for example FTP or FTP or TFTP, and usually is a dedicated physical virtual platform with a lot of other added features. Like in general, it also supports routing, switching, VPN, intrusion prevention systems. So to go back to the initial case, for example, in here, if this would be a stateful firewall, rather it would be a stateful firewall, and the firewall policy, let's say, is going to allow, assuming that from back in the days, this would be my trusted side, the LAN, and this would be my untrusted side, the internet. From back in the days, we know that traffic is allowed to flow by default, let's say from the trusted to the untrusted side, or you would configure that. So traffic is going to be allowed to flow this way, freely. But then in this use case, when router 2 initiates a session towards router 1, let's say, then what happens is router 2 sends the first packet, packet number 1. If the firewall allows the packet, which is going to allow, it's going to send the packet as well. It's going to route the packet for the destination. But as it does this, it's going to also create an entry for the session in the firewall state table, which is going to in that state table is going to identify the exact layer 3 and layer 4 attributes of the session. So if that was a TCP session, you're going to see in the state table, you're going to see when you go to the implementation side on the SA firewall, you're going to see the source address, destination address, layer 3, the layer 4 protocol, TCP or UDP, the source port, destination port. If it's TCP, you're going to see also the flags, if the tree handshake was achieved or not. So it keeps an exact state of the session as packets are flowing back and forth to the session. So when the second packet shows up, the router is first going to look in the state table. It's going to check the state table, and because it's going to see an entry matching the exact source destination IP address and source destination port and layer 4 protocol of the second packet is in the state table, is going to make sure that the second packet is confirmed with the current session state in the state table. So it's going to make sure that if it's a TCP session, for example, it is going to make sure that it comes up the second packet with the proper sequence number, for example. And then of course it's going to allow the packet further. So as the first packet came in, so a stateful firewall, what it does, whenever it's going to receive a packet, it's going to first look in the state table of the firewall to see, do I have an entry in the state table for this session? Because if I do, I'm going to make sure that the received packet matches what I should expect to receive based on the state table, based on the entry of the session in my state table. So when it receives the first packet, there's nothing in the state table. It is the first packet of a session. The firewall just allows the packet if it's allowed by the firewall policies, and also is going to create an entry in the state table. When the second packet shows up, the firewall says, okay, let me look in the state table. Do I find in my state table an entry matching this packet's layer 3, layer 4 attributes like ports and IP addresses and protocols? And if yes, it's gonna say, okay, is the second packet, this received packet, is it what I should expect to receive based on the current state I have for this session in my state table? And if yes, it's gonna allow the packet and change the entry in the state table for that session, because it's gonna update the sequence number, for example. And then it's going to forward the packet. Behind the scenes, of course, the stateful firewall does much more than this, but just to keep it basically, you have to understand that it's going to keep a state of the session. It is session aware, so it's going to be in better, let's say, it's going to be able to better secure the network, because it's not only going to allow the traffic back and forth blindly, it is going to track the session state. And likewise, for this use case, like for example, let's take this example again. And if this was a stateless firewall, this time a stateless, okay? Which means that you would have, let's say, this would be the trusted side of the network, this would be the trusted side. Likewise, and this would be the untrusted side. If this would be a stateless packet filtering, it means you're going to have an inbound ACL in here, inbound ACL, to control traffic flowing in this direction from LAN to the internet, and an inbound ACL likewise in here on the untrusted interface to control traffic flowing this way from the untrusted side to the trusted side. So you're going to have an inbound ACL on both sides of the router of the firewall to control both traffic from the LAN to the internet and from the internet to the LAN. So what this means is that, for example, because the firewall doesn't keep track of the session, it just allows traffic on a per packet basis. So let's speak about the inbound ACL, which was in here applied, inbound. If router 2 is going to initiate a session with a source of its loopback, destination router 1 loopback. This was going to be a TCP session with a port number, with a source, with a random source number, and destination with a port number of, let's say, 293. That would be is going to be a telnet session. So this would be a TCP session between the loopbacks of 2 and 1. Of course, the source port is going to be random, destination port is going to be 23. So it means that this inbound ACL has to allow that specific traffic with that source, that destination, and those ports, source and destination. So assuming the firewall is going to allow this packet to go out, when router 1 replies, router 1 is going to reply with a source of 10111, port 23 as the source, and destination of 10222 with a destination of a random port number. So as this packet is received, is going to be sent by router 1 to router 3, which is my stateless firewall, and as that firewall has an inbound ACL applied, it means that in that ACL, I gotta make sure that this traffic is allowed. So in this ACL, in here, in this access list, I gotta make sure this traffic is allowed. In this ACL, I gotta make sure this traffic is allowed. So because the firewall doesn't keep is not aware of the session state, doesn't keep track of any packets which itself has been routed back and forward, because I had two ACLs supplied in both firewall interfaces to control both traffic from the LAN to the internet and from the internet to the LAN, in order to allow a session from the LAN to the internet to flow back and forth, I have to allow the session in both access lists. I gotta allow in the LAN side in the LAN side facing ACL, I have to allow the session to be initiated. And in the internet side ACL, I gotta allow the session return traffic. So you see, it's not scalable, and of course, because the firewall doesn't keep track of the sequence numbers of the TCP session because it's stateless, it cannot even protect against sequence number spoofing, which is TCP spoofing. So a lot of other problems except scalability and configuration. But if this would be a stateful firewall, so I'm going to change this around, and if this would be a stateful firewall now, and I'm going to take the same session. So if this would be the same example, but now with a stateful firewall deployed. And let's say that on this inbound ACL in here, on this inbound ACL from the LAN side, I only allow this traffic from router 2 to router 1. This is what I allow in that inbound ACL. And on the inbound ACL from the internet in here, I say a deny any. I don't want anybody to come in from the internet into my network. I don't have any public services. I just want to allow users to go out on the internet. So that means that nobody can initiate packets from the internet to the LAN side. That is going to be dropped because it's going to match on the inbound ACL, which says a deny IP any. But because this is a stateful firewall, it means that when router 2 initiates the packet, then the router 2 is going to match it against the inbound ACL, and the inbound ACL allows the packet. Which means router 3, my stateful firewall this time, is going to route the packet out to the destination. But at the same time, is going to put in the state table. At the same time, is going to put in the state table an entry in the firewall state table matching that session. So it's going to put in the state table exactly that he has seen and allowed a packet source from router 2 destined to router 1 on those port numbers and TCP and with the exact sequence numbers. So what happens now is that when router 1 replies, of course with this source of 10.1.1, destination of 10.2.2.2, when router 1 replies now, the first thing that the stateful firewall is going to do is not going to look in the inbound ACL. It's going to look to see if it's going to look in the state table to see, do I have a matching entry in the state table for this packet? And it is going to find an exact entry in the state table. So now, because this is a stateful firewall, the firewall is going to say, oh, this is the return traffic of a session which I allowed to go from the LAN side to the internet, and I'm a stateful firewall. I created an entry in the state table, and even though all inbound traffic from the internet is dropped, that's for new traffic, new sessions initiated from the internet. But a stateful firewall is going to always allow the return traffic back in the network. So there we go. You don't have to allow both the initiating traffic and returning traffic as with the stateless firewall. With the stateful firewall, you just allow the traffic to be initiated, and backwards the return traffic, you don't have to allow it in the return path ACL. It's going to be allowed by default because that's how stateful firewalls are working.